Okay, hello. Let's look at formal charge, assigning formal charge. It's good, tough topic. Or actually, not really that tough, but it really does pop up everywhere in your chemistry endeavors. So you really need to be vigilant and eventually get quite good at just assigning this quickly. So we have a carbon bound to 3 hydrogens, and we have an oxygen with 3 lone pairs. So the way to calculate formal charge is really simple. You do number of valence electrons minus dots minus lines. So this is really simplified. Dots obviously are just electrons. So number of E minus on diagram, or much simply just number of dots. And number of lines is just the number of bonds. So if you have a double bond, it'll correspond to 2 lines. If you have a triple bond, it'll correspond to 3 lines, and so forth. So we'll start with this carbon. I like to just kind of, whenever I have these problems, I like to just have the carbon and draw the arrow. Has 4 valence electrons. How many dots does it have? It has 0. So just 0. How many lines does it have? It has 1, 2, 3, 4 bonds. So it has a formal charge of 0. Now we'll have this oxygen. How many valence electrons does oxygen typically have? You can just look at a periodic table. It's 6. How many dots does oxygen have? He has 1, 2, 3, 4, 5, 6. It's not a he. Atoms do not have pronouns. And lines, it has 1 line, 1 bond. So this equals -1. So we have an overall charge of -1. So you kind of like this, and then -1, like that. That's how you could draw it. But there's a negative charge right there. Okay, sweet. So that's our first problem out of the way. Now we will run it back with this nice little problem here. Bound to like this. So we have 2 carbons here. You can either like kind of draw an arrow. Pretty much the easiest way to do that. And then the formal charge of these hydrogens, I actually didn't explain in the last problem, but I will. It's the same thing, dots minus, or valence electrons minus dots minus lines. This has 1 minus 1, which equals 0. And it's the same thing for all these, which I hope you can see. So, wait, this can't be legit. No, this cannot be right. This is bound to carbon, which is like this. Apologies. It'll be this. Bang, bang, bang. Like this. Totally disregard this. That cannot exist. Same thing here, though. This is just 0 formal charge for the reason I explained. This guy, 4 minus 4 minus 0. 4 valence electrons normally, 4 lines, 0 dots, which equals 0. Sorry if these are out of the order. It doesn't actually matter which way you subtract it, just so that you know what you're doing. 4 valence electrons typically. There's 1 line here, 2, 3, 4 lines. No dots. This carbon right here. 4 electrons normally. 2 dots, 3 lines. So 1, 2, 3 lines. I'll try and be consistent. 2 dots, which equals -1. So then formal charge of this atom is -1. Okay, perfect. I think I'm suffering from a cold. Jeez. We'll finish up with a tougher problem. Give me 2 seconds. Also, credit to University of Calgary. They published this problem online. I did not make up this problem. Okay, wonderful. Okay, formal charge, so we'll do all the atoms. If you see hydrogen with 1 bond, which I think you pretty much always will, it's a formal charge of 0, so we can just draw 0 just to be consistent, or concise, coherent, comprehensive. That's what I'm looking for. This oxygen, dot, valence electron 6, dots minus bonds 1, 2, 1, 2, 3, so 3 minus 2 equals +1. Wow, oxygen with a +1 charge, very unstable. If you see that in a resonance structure, not great. Oxygen is very electronegative. Carbon, 4 lines, 0. I didn't draw the dots. There's 0 dots. This CH3 is called a methyl group. 1, 2, 3, so 0. And this is 0. So formal charge overall is 1. And now, unfortunately, what none of these problems encapsulated, but I do want to share, and what I'll try and make up on the spot. So give me some kindness if I mess up. I'll just double bond to a carbon, and then I'll take this. So this is just a single bond. So this is, we'll walk through the formal charge of this because this is a little bit more complex. So you get oxygen, so it's 6 minus 2 minus 3, which equals +1. This carbon is 4 minus 0, which equals 0. This carbon here, this is not a bond. This is a bond. It's a single bond. So it's, I'll just drop 1 sigma to make that clear. 1, 2, 3, 4, 5, 4 minus 4 minus 3 minus 2, which equals -1. And then this oxygen, which I'm just going to redraw this, which I should have done at the beginning. This oxygen has 6 normally. It has 1 line, 6 dots, which equals -1. So now we have this interesting situation where we have a +1 formal charge on this dude, a 0, a minus formal charge on this dude, and a minus formal charge on this dude. So what you do is you add up all the formal charges. You could have like +2, I'm sure, potentially. So you just add up all like the values. So we have +1 plus -1 plus -1, which equals -1 overall. So like the overall charge is -1, which I will draw like this. That is the overall charge. So there you go. That's how you can calculate formal charge. So the formal charge, for example, if you're asked what's the formal charge for the oxygen here, it's -1. What's the overall charge of the molecule? It's +1. What's the overall charge of this oxygen here? It's -1. Sorry, this is overall charge is -1. I think you get the picture. Thanks for watching. Take care.